Hello guys, in this video I would like to explain about different levels of measurements. You can say data, and this is very useful video for understanding about different levels of measurement or different levels of variables or different levels of data. So mainly there are four basic levels of data, which will start from the lower level to the higher level of data or measurements. So let's move to the content and see what we have. Uh, the first level is of data is nominal level data. Refers to the most basic level of measurement and statistic where data is categorized without any specific order or ranking. It involves labeling or naming items into distinct categories that do not have a numerical or logical order. So that is quite obvious that in this category we just categorize, name the data or label the data with some distinct categories which do not have numerical or logical order. And now we move to the key characteristics so we can explain, and then after that we have example of this data so you will understand the concept of nominal level data in detail. Key characteristic of nominal data. Categorical data is divided into categories or groups, different categories or groups. No order. The categories have no intrinsic ranking or order. For example, red is not greater than blue. Yeah, so this is like this. So in different categories, but they have no numerical or logical order. So you cannot say that red is better than greater than blue, or red is blue is better than red. So no. Qualitative nominal data represent qualities or characteristics, not quantities. Labels only. The numbers assigned to categories, if any, are purely for labeling and do not imply any numerical significance. So yeah, we can label, but does not mean some numerical significance. These are the examples of this nominal level data: gender, male, female, or other. Hair color: black, brown, blonde, red. Country: USA, Canada, Japan. And types of car: sedan, SUV, and trucks. So it's a different cars. So all are the categories, and you cannot say this particular category is greater than or whatever like this. So it's only categories. And now at the end, I have mentioned that which type of statistical analysis you can perform with each category, with each level of data. In nominal data, the only statistical analysis you can perform is counting the frequency of each category or comparing whether two values are same or different, e.g. mode or frequency distribution. So this does not mean that you are comparing different individual values, or you can compare their frequencies there, which which category is higher in numbers, in fact, in frequency, in fact, not an individual category. You cannot compare like that. As you already talked, red is not greater than blue like that. So you can compare only in number of frequency. Numbers are in frequency, different categories. The next level is ordinal level data, refers to type of data that involves categories with a meaningful order or ranking, but the interval between the categories are not necessarily equal or measurable. So this is another data which cover the disadvantage, or you can say the issues which we had already with the nominal data covered by ordinal data, that there is ranking or order, but the problem is that the interval between the categories are not necessarily equal or measurable. So this is the problem with this data. The key characteristic of ordinal level data: categorical with order. The data consists of categories that can be ranked or ordered. So this is the advantage of this data over the nominal data, that we can ranked or ordered. Unequal intervals. While the data is ordered, the difference between categories may not be uniform or known. E.g., the difference between first and second place may not be the same as between second and third place. So this is unequal interval. This is a problem in this data. Relative comparison. You can say one value is higher or lower than the other, but you cannot quantify how much higher or lower in precise terms. So this means that you can compare the values, that particular value category is higher than or lower than the other, but you cannot precisely quantify that amount. Example of ordinal level data: education level, high skill, bachelor's, master, PhD, customer satisfaction, whereas unsatisfied, neutral, satisfied, very satisfied, socioeconomic status, low, middle, high, ranking in a competition, first, second, third, and so on. And now the question is, what type of statistical analysis you can perform using this ordinal level data? Ordinal level data allows you to perform non-parametric statistical analysis, such as calculating the median or using a rank-based dataset to experiments, rank correlation. However, the arithmetic operation like addition or subtraction are not meaningful for ordinal level data. So you can use like a ranking analysis, which is now usually we call these are part of the non-parametric analysis. You can do non-parametric analysis, but however, due to the nature of the data, you cannot do addition, subtraction, and this type of analysis on ordinal level data. The third level of data is the interval level of measurement is the next highest level. It includes all the characteristics of the ordinal level, but in addition, the difference between values is a constant size. So this overcomes the issue which was with the ordinal level data. So this core all the all this the highest level, it includes all the characteristic of the ordinal level data, but in addition, the difference between values is a constant size. So this is a plus point. That's why this is the next higher level data. Key characteristic include order with equal intervals. The data is ranked and the intervals between values are equal and measurable. So in this case, this is can be measured and have the equal interval size. No true zero. The scale does not have an absolute zero, meaning that zero does not indicate the complete absence of a quantity being measured. So we will talk about this in the example. So we will explain what is meant by no true zero. Addition and subtraction, you can add and subtract values, but multiplication and addition are not meaningful due to the lack of the true zero. So this is the problem with this data. You can do other calculation, but multiplication and division, you cannot do that. Example of interval level data. Temperature in Celsius or in Fahrenheit. The difference between 20 degrees centigrade and 30 degrees centigrade is the same as the difference between 30 degrees centigrade and 40 degrees centigrade. But 0 degrees centigrade does not mean no temperature. I already talked about no true zero. So this is the explanation that 0 degrees centigrade does not mean no temperature. There is a temperature which is 0 degrees centigrade. IQ score. Difference between IQ scores are meaningful, but there is no absolute zero I score. Calendar year. The difference between 2000 and 2020 is 20 years, but there is no meaningful year zero that represent a complete absence of the time. So these are the example and the interpretation basically from using the example of no true zero on the scale for interval level data. Now, what types of calculation and for analysis we can perform with this level data? With the interval data, you can perform a wide range of statistical operations, including calculating the mean and standard deviation, but ratios, e.g. saying one value is twice as much as another, are not meaningful due to the lack of an absolute zero. So you cannot do the ratios and like the comparison because of the lack of the true zero. And this is the highest level data, highest level of measurement. Ratio level data is the highest level of measurement in statistics, with where data not only has meaningful differences between values but also has a true zero point. This allows for all range of mathematical operations, including meaningful ratios, i.e., one value can be expressed as a multiple of another. So this is the highest level of data which have all the characteristics of the previous level data, the interval level data, but also include overcome the problems of no true zero. So then you can do a lot of operations and calculation on this data, mathematical operation, including meaningful ratios also, which is comparing one variable and the multiple of another. Key characteristic include order with equal interval. Like interval data, ratio data has equal and variable interval between variable values. True 0 point, a value of 0 represents the complete absence of the variable being measured, making it meaningful to say that one value is twice as much as another. So this solved the problem of no true 0, and a value of 0 represents the complete absence. Yes. So this is now another. I mean that this is the plus point of this data as compared to the previous data sets. All arithmetic operations, you can perform addition, subtraction, multiplication, and division on ratio data. Ratios between data points are meaningful in this case, as we have true 0 in the scale. Example of this data, ratio level data. Height of 0 means no height, and a person who is 180 centimeters tall is twice as tall as this, someone who has 90 centimeters. Weight, a weight of 0 indicates no weight, and a person weighing 60 kg is twice as heavy as someone weighing 30 kg. As a person who is 40 years old is twice as someone who is 20 years old, and 0 years mean no age. Income, a person earning $0 has no income, and someone earning $100,000 earn twice as much as someone earning $50,000. So that's obvious, very clear from this example that this overcome the limitation of the previous data set. Now, what type of calculation? We already have talked about this, but ratio level data we can talk here as well. Ratio level data allows for the most advanced statistical analysis, including calculating geometric mean, ratios, and proportions, in addition to basic operation like mean, median, and standard deviation. So you can do a lot of operations if you have this type of data. So this is all about level of measurement. We have 4 level of measurements. That is nominal, which is the basic level of measurement. The second is ordinal level, which is the second highest level, and the third one is interval level of measurement or data, that is the third highest level, and the last one is ratio level of measurement, which is the highest level of measurement. And of course, with each level you can perform different operations. Like with the highest you can do a lot of operations and calculations, and with the lowest you can do very limited calculation, like only frequency calculation, and you can do frequency comparison. So this is all about level of measurement data or data. If you have any question, please write me in the comments. And this is enough for today, and see you in the next video. Ciao.